Hey, this is Don from Padlock Technologies again with another video. As promised, we are doing the MPLS segment routing lab here. So this is going to be basic MPLS SR. This is not going to be MPLS SRTE. So we're just going to go over the basics. If you don't know anything about MPLS SR, I'm going to put a card up here with the video to the theory video. Watch that before you watch this. If you watch that before you watch this, this will make a lot more sense. If you do it in reverse, this kind of won't make any sense. First thing I'm gonna do though is I'm gonna fix this because here's my OCD kicking in again. Let's see. Let's move that back over here. And then we unlock it. All right. So here we are. Simple lab. You've seen this in the MPLS TE video that was doing RSVP. This time again, we're going to do segment routing. I have a bunch of L3 VPNs going around here. So I have EIGRP, OSPF, BGP, and RIP of all things. I have RIP running in this MPLS network. And then the ones with the purple, I'm doing just an L2 VPN. So this is going to be doing VPLS instead of VPWS. So there is going to be some MAC to pseudo-wire binding on this one. So let's talk about, I'll use router 4 right now for the demonstration. So just to validate that MPLS or LDP is not running in the environment, we do a simple show MPLS LDP neighbor, nothing there, right? So that definitely validates that LDP is not running in this environment. And then we're going to do show MPLS forwarding table. You see there's labels. Now those labels are generated by using the SR technique and having the IGP or have the label carried in the IGP. So what you see here is the prefix label, which is the prefix label is basically the node label or the label for the router itself. Now I'm going to show you in the segment routing commands that you're going to see something that solidifies or it specifies that the loopback address is going to have the absolute value of a certain number. So router 1 has 16001, 2 has 16002, 5, 6, 7, all going to be 1600 something. But what I want to draw your attention to is these adjacency SIDs. So adjacency SIDs allow you to do TILFA, right? And if you look at the video, the theory video, what TILFA is, it allows you to basically push traffic through your network, no matter what the topology is, right? And you're going to use the adjacency SIDs to do that, right? And TILFA actually gives you 100% coverage in terms of finding a backup path in case of for convergent purposes, right? So anything that's an adjacency SID is a link SID or a link, and then it is a an adjacency SID is basically the link, right? So the link on the router is the adjacency SID. So if you look at these numbers here with an A on it, these are the links, right? And then if you see anything that's a prefix SID that's at /32, that's basically the node, all right? Now let me expand this just a little bit more here. Now, if we look at the database, so if I look at if I do show, let's see, show, I don't know, on my agents, show ISIS database. Now, if I do just regular show ISIS database, you're only going to see the level 2 database because the routers are just all level 2 routers, right? Now, remember in ISIS, there's a level 1 and a level 2. So if you see that, that doesn't really tell you anything, right? Now we're going to verbose it so we can look at a little bit more data. So as you can see, these values here with the L and all that good stuff shows you that it's an adjacency SID. It says it's adjacency SID anyway, right there, and it says L1. Now for a node SID, we're going to scroll up here, and they will call it a prefix SID, right? So right here is the loopback address, which is 10 255.255.1/32. And as you can see, the N flag is set to 1, so that lets you know it's a node SID, right? Now you can do a certain thing where you can remove the N flag, so you can do something called anycast SID. And the anycast SID would be, hey, if I have a loopback, say if I had 10.255.255.1 on 2 routers, well, what I can do is remove the N flag, and now I can go to any one of my routers to navigate through the MPLS SR network. But that's a more advanced technique, and you're usually going to use iOS XR for this. In this example, we're doing iOS XC. So first thing you need to do, though, is you need to do segment routing in the global configurations. You need to turn it on. So if we do show run segment, we'll just do that. This command right here, here's the first command. You need to turn this on globally with segment routing MPLS. Next thing you need to do is you need to do the prefix SID. Now in iOS XR, you have to do this in a separate menu. In iOS XE, you do it under the routing process. So if you're using OSPF or ISIS, you would do it under the either process, right? But in iOS XE, you have to do it in a couple different locations. This one here is just saying, hey, we're going to do segment routing MPLS. We're going to do a connected SID map. So we're mapping the SID to the loopback. We're going to say it's IPv4 because we're doing IPv4. And then we're going to say, hey, this address of 10.255.255.4/32 is going to have the absolute value of 16,004. So that means in the SR domain, this router is the only one that's going to have that that label, right? That SID value. And when you look at the trace route, you're always going to see that value as the transport. Even if it's swapping, that label is always going to be 16,004, or in this example, it'll be 16,001 or 16,002, because everybody's going to know that that label is for router 2 or router 1, and they're going to, in their label bindings, they're automatically going to allocate 16,001 or 16,002 in their lib. So it's always going to be that value as the transport value when you see the trace route. Now the service VPN is going to be whatever BGP decides to allocate as a service or VPN value or VPN label. Now that's just at the global level. Now you have to turn it on at the router level too. So you have to go into the router process and use a command called segment routing MPLS. So if we go into the router, and as you can see here, here is ISIS, here's the process. And I just want to draw your attention to the segment routing MPLS. Once you turn that on, segment routing is working. And then that's when we got the show MPLS forwarding table. And there you go. That's how the labels are, these labels are actually being carried in ISIS, okay? Which is different from normal MPLS like you learn in your CCIE Enterprise, which you're going to be using IGP, LDP, and BGP. You're taking out the LDP requirement when you're using segment routing. Now, there's a lot more stuff that you can do, like MPLS SRTE, which comes in with the PCE or path computation element, and the PCC, which is the path computation client. The client asks the element to give me a path, and then the element will calculate a path and then install that path into the client. So it's a little bit of SDN, right? Because now it's taking the control plane off of the client and moving it to the PCE. If you want a video about all that, let me know in the comments, and then I'll lab it up and then show you, SRTE with, the path computation element or a little bit of SDN, right? So now that that's all over with, we're going to go here on router 1. If I do show BGP, VPN v4, unicast all, here's all my stuff in the VPN v4 table. Now, I have not done any route leaking, so everything in the separate VRFs do not know about each other. If I wanted to do some route leaking, I would just import the export value into one of my VRFs and then do the same thing vice versa, and those things will know how to get to its respective loopback based on the leaking if it was outside of the VRF. I may just do that depending on how long this video is. I may just show you that, what it looks like. So let's go with the R13 here. And R13 is a part of 116. So we're going to try to ping R11. So R11 should be in my routing table here. So the loopback should be in there at least. So show IP route. I think this is EIGRP. Or no, let me see. Show IP route. Oh, this is okay. I'm using OSPF on this one. So you can tell that by inter-area route, right? So in MPLS, it's always going to be an inter-area route unless you use something like a sham link, which makes it a intra-area route. So this one is saying this is an inter-area route here. But if I was using a sham link or something like that, I can make this go from an OIA to an O. But that's neither here or there. So now let's just validate that we can ping it. So we can ping 10.2.11. We're going to source it from our loopback. Ping is working. So now we're going to trace route 10.255, 255, 11. If I spell trace route right. And then we'll source it from loopback 11. And I want you to pay attention to the MPLS labeling as it goes through the MPLS network. So what you should see is the same label. So we're going to 2, right? So you see 16002 as a transport label all the way through that network, right? So what you're going to do is we should see it coming up pretty soon, which is 116.002. The service label is going to be 28, so that's the VPN label. And it's going to be 16002 again. Service, as you see, as it's going through the network, it is always keeping the 16002. So it's not ever going to change because that 16002 has been allocated to every router in the network that says, hey, this belongs to router 2. Now, as you can see, once we got to router 2, right, we only have the service label. So right here, which is 16.61, this is router 7. So the our penultimate hop popping happened here, get to the normal service label or VPN label, and then that got popped off and it became an IP packet. So that is what happens when you do a MPLS SR network versus a normal MPLS LEP network. So the other thing here that I wanted to show you is this is running show IP EIGRP neighbor. So this is my L2 domain. So I'm doing another L2 emulation here, but I'm using VPLS versus BPWS. So right here, if we go and look at the bridge group in router 1, so we show bridge group, or bridge domain, not bridge group, 11, we have our MAC addresses that are mapped to pseudo wires. As you can see, this is VPLS, and I'm using the Capella method, not the Martini method. Martini method is LDP signal versus BGP signal, which is the Capella method. And you can validate that by going to show run section. I'll just show you the VPN, L2 VPN stuff. So as you can see, we're going to be in VPN ID 0. Everybody that's in the same VPLS domain needs to have the same VPN ID. We're going to use BGP for auto signaling, and virtual edge ID is 1. The other one is 2 on the other router. And this command right here is going to suppress LDP. So we are using Capella and not Martini method. So as far as the route leaking goes, so I will do router 14. So if we look at router 14 and we do show IP route, I think this one is the EIGRP. So as you can see, we only know about router 8 and me locally. So what I need to do is I need to go into here and I think my VRFs are cut. Let's see. All right, so we have 16 and 17. So what I'm going to do here, we're going to go into VRF definition cus 16. And we're just going to import that value. So I think that route value is route target import 65001. And I think I did .17. And then let's go into the other VRF. 17. And then we're just going to route target import 65001. I believe this is 16. Now, give it a little bit of time here, unless I got the route targets wrong, which can happen. Let's see here. All right, so I'm importing 17's value and 16's value. And let's see what we got. So I got router 8 and I got router. I probably need to redistribute into here. Let's see. I think this is router EIGRP. All right, let's look at. So I want to do VRF. Plus 17. See what we got here. We got 13. All right, so we got 13 in here. So why is 13 not coming back down? There we go. Just took forever. I hate when it does that. So we did some route leak in here. So now we have 13. Now it's being seen as an external route. Because it's a different process and all that good stuff, but it's being seen as an external route. So I have 13, which is this one here. And then I have 11, which is this one here. So now the only thing I need to do on the other side, which is on 2, which this should hopefully not take as long. So we'll do the same thing here. So VRF definition cus 16. And route target import 117. And then VRF definition cus customer 17. And then route target import 65005. 65001, sorry. 16. So now we should be able to see router 14 on router 11. Now this may take the same amount of time though. I think this is OSPF. Yeah. So let's see. So yes, we see 14 and we see 8. So now if I'm going to ping 10, 255, 255, 14 from the loop, bang. And that's route leaking in a nutshell. So how did that work? Very simple, right? All I did was take the RT value from the VPN v4 table and inject it into my VRF by importing that RT value. So on router 2, if I do show BGP VPN v4 unicast all, and I do 10, 255, 255, I believe 14/32. What we are looking for here is this RT value right here, this extended community. So anything that's in my VPN v4 table that has that RT value, if I import it, it automatically goes into my VRF, right? So when you export it, you export it into the VPN v4 table with that extended community. And that's what, some people say you join the VPN, but you're not joining the VPN. What you're technically doing is looking at the VPN v4 table that everybody shares, and then you're looking for that route, and you're looking for that extended RT value, or the extended community, which is the RT value, and you're saying anything that matches this value, import it in my VRF when you use the import command. And then when you export your stuff into the VPN v4 table, you just say, I'm going to export any route that I know of with this RT value. If anybody imports it, we're going to share routes. So that is SR, or MPLS SR segment routing in a nutshell. As you said, is a very different technique because you're not using LDP. The IGP is actually carrying the label. And then you saw some route leaking between R3, our MPLS L3 VPNs. So you saw some route leaking there. This was OSPF and EdgeRP, but I could have did it with BGP or RIP. And then you saw L2 VPN with VPLS instead of VPWS. So I hope this video was informative. Please don't forget, share, comment, like, and subscribe. I really enjoy the questions that you're asking me, and it allows me to get some technology that I haven't did for in a while. So this is Don from This is Don from Padlock Technologies again. Thank you. Have a nice day.